Hello everyone. Our lesson today is about factoring techniques, and we're going to specifically be looking at 4 techniques. The first one is GCF, or greatest common factor. The second one is called dots, or difference of two squares. The third one is called grouping. And the fourth one is factoring a trinomial. So let's start with the first technique, which is GCF, or greatest common factor. Let's take some examples. So let's say I have an expression that looks like 2x minus 6, and I want to try to factor this. Notice that the first term is 2x and the second term is 6, and there is a minus in the middle. We need to identify the greatest common factor. Looking at the first term, it has a 2 in it. The second term is a 6. And the 6 is made out of a 2 times 3. We can see definitely that we have a 2 that is in common that we can pull out. To find out what's left, we take 2x, we divide it by 2, we get an x. We get the 6 divided by 2, we get 3. We have completely factored using the greatest common factor being 2 in this case. And we can always check our answer by taking that 2, multiplying it back in using the distributive property to check our answer. Let's take another example. If we have 3x squared plus 18x, again here we have 2 terms. We need to identify the greatest common factor. Our first term is 3x squared. Our second term is 18x. Looking at the numerical portion, we have 3 here. We have 18. And the 18 is of course made out of 3 times 6. So we can definitely identify the 3 being greatest common factor in the numerical portion at least. Now looking at the variables, we have x squared in the first term and we have x in the second term. We can identify that there is an x that is in common. So now my greatest common factor is 3x. To find out what's left, we take 3x squared, we divide by 3x, we get x, plus now 18x, which is the second term. When we divide it by 3x, we end up with a 6. And we have completely factored using GCF. Again, we can definitely check our answer by taking the greatest common factor, which is 3x here outside, and multiplying it with everything inside using the distributive property to check our answer. Moving on to the second technique, which we called dots. And dots, from the name, you have to have a difference of 2 squares, which means your expression should look like 2 perfect squares with a difference or a minus sign in the middle. This is where you identify that dots is the best technique to use. So let's take some examples. So let's say you have x squared minus 1. Let's check. Do I have 2 perfect squares? Yes. And I have a difference in the middle or a minus? Yes. So I can use dots in this case. And the way to factor using dots is very easy. You open 2 parentheses. Looking at the first term here, which is x squared, can be broken into an x and an x. So when you multiply them, you get x squared. And now for the second term, which is 1, if you take the square root of it, it's 1 times 1. Put a plus here and a minus here, and you have finished and factored completely. Easy, right? Now let's take another example to make sure that we understand how to use dots. So let's say you have x squared minus 16. Again, you have 2 terms. Each one is a perfect square and there is a minus in the middle. We can definitely use dots here. So we'll open 2 sets of parentheses. We'll break the x squared into an x and an x. And now the 16, it's 4 and a 4. And we put a plus and a minus. We have completely factored using dots. Again, you can check by foiling. Let's take another example. 2x squared minus 50. Now looking at this example, it is a difference of 2 terms, but notice that the 2 is not a perfect square. 50 is not a perfect square. So in this case, we cannot use dots right away. But what we can do is we can find a common factor first, which is in this case is 2, because I have a 2 here, and 2 is a factor of 50. So if we pull the 2 out as a common factor, so now we're not really using dots, we're using GCF. To find out what's left, we're going to take 2x squared and divide by 2. We end up with x squared minus, now 50 divided by 2 is 25. We have factored using GCF, but we are not done. Notice that x squared minus 25 is actually a difference of 2 squares. So we should continue and factor this part using dots by opening 2 sets of parentheses. We break the x squared into x and an x, and the 25 is a 5 times 5, and we can put a plus and a minus here, and this way we have used actually 2 techniques to factor this problem. And some of you might ask, doesn't matter if I put the plus here or the minus there or switch them? It really doesn't matter because multiplication is commutative. So you have factored here this problem using 2 techniques actually. Okay? Now moving to the third technique, which we said it's grouping. And grouping usually works when we have 4 terms. So let's take an example. 8x cubed minus 64x squared plus 5x minus 40. Notice here that we have 4 terms. This is my first term, 8x cubed. 64x squared is my second. 5x is my third. And 40 is my fourth term. Now the way grouping works is you're going to be actually doing GCF for the first 2 together and GCF for the second 2 together. So grouping is actually doing GCF, doing the greatest common factor, but doing it more than once. So let's look at the first 2 terms first. You have 8 and you have 64. We can identify 8 as being a greatest common factor. Now we have x cubed here and we have x squared here. So we can definitely pull x squared as a common. To find out what's left, we take 8x cubed, we divide it by 8x squared, we end up with an x. Now we take 64x squared and we divide it by 8x squared, and we end up with an 8. Now looking at those 2 together and finding GCF between them, we're going to, this plus here, we're going to just put it down. Now let's look at those 2 terms. What is the greatest common factor that we can find between 5x and 40? We can identify that the 40 it has a 5 in it. 5 is a factor of 40. So we can pull 5 out as a common factor. And now we take 5x, we divide by 5, we get x, minus 40 divided by 5 is 8. Now if you have done your factoring correctly, you will always notice that this part will repeat, which means it is in common between those 2 terms. So if we pull it as a common factor from each of those 2 terms, after we take this out, we end up with 8x squared from the first term and a plus 5 from the second term. And we have completely factored our expression. Okay? Let's take another example just to double check that you understood what I was saying. So let's say we have 3x cubed plus 21x squared plus 7x plus 49. Again, the way grouping works is by doing greatest common factor for 2 terms at a time. So looking at the first 2, let's identify our greatest common factor. We have a 3 here and a 21. The 21 is made out of a 3 and a 7. So we can definitely pull the 3 as a common. Now we have x times x times x to give us x cubed. And here we have x times x to give us x squared. So we can identify that we have x squared in common. Now to find out what's left, you take 3x cubed, you divide by 3x squared, you end up with an x, plus, now 21x squared divided by 3x squared is actually a 7. You put the plus down. Now let's look at those two terms together and find a greatest common factor. We have 7x and we have 49. And remember, the 49 is made out of a 7 times 7. So we can definitely identify that 7 is a common factor. And we can pull it outside. To find what's left, you take 7x, you divide by 7, you end up with an x. 49 divided by 7, you end up with a 7. Again, you see this term, this part, has repeated. So we can pull it outside as a common again. And what we have left from the first term, after pulling x plus 7 out, you have 3x squared. And from the second term, which is this one, after you pull x plus 7 out, you have 7 left. And you have completely factored. And again, just with like the previous two factoring techniques, you can FOIL this to check your answer. So the way grouping works is you have 4 terms and you are doing GCF for 2 at a time. Now the last technique is factoring a trinomial. And I'm gonna give you 2 examples. The first example is x squared minus 6x plus 5. The reason it's called a trinomial because it has 3 terms. This is my first term, x squared, 6x, and a 5. The way this would work is you would always look for 2 numbers that give you a product of 5, which is the constant term here, and a sum of negative 6. Try to find 2 numbers that multiply to 5 and give you a sum or a difference of negative 6. Well, the only 2 numbers that multiply and give you 5 is 1 and 5. But notice that the sum is negative, which means if I want to add those 2 and get 6, I need both of them to be negative. Now you are gonna factor immediately using breaking the x squared into an x and an x, and then you put a negative 1 and a negative 5, which are the 2 numbers that we got over there. Let's take another example. If we have x squared minus 9x plus 20. Again, you are looking for 2 numbers. Their product is 20. And their sum or difference is negative 9. Remember here, this technique works only when a is 1, when the coefficient of x squared is 1. Notice that the number that's multiplied by x squared here is 1. There is another way when the number in front of x squared is not 1 that we can do in a later session. So let's try to find those 2 numbers that we're looking for. What 2 numbers multiply to 20? Well, there's plenty of combinations. There's 1 times 20. There is 2 times 10. There is 4 times 5. But which ones of those combinations? Let's write them. So 1 times 20 is an option. 2 times 10 is an option. We have 4 times 5 is an option. But the only one that would give me a sum or a difference of 9 is the last one. So the 2 numbers that we need are 4 and a 5. But notice that the sum is negative. So those 2 numbers have to be negative. Now we're going to factor by opening 2 sets of parentheses. We'll break the x squared into an x and an x. And we'll use those 2 numbers that we just got, the negative 4 and the negative 5, to put them here. Now we have completely factored this problem and we can always check our answer by FOILing. This concludes our lesson. We will investigate more techniques later